Welcome back. Let's do question 2. Given the arithmetic series 7 plus 12 plus 17 goes on like that, determine the value of T91. So this is an arithmetic series, but we want to find a term here. So we're going to use the arithmetic sequence formula. Remember, Tn is equal to A plus N minus 1D, right? Our A is equal to what? 7. Our N is going to be 91. We're finding term 91. And then our D, the difference, 12 minus 7, that is 5. 17 minus 12, that is 5. So our difference is 5. Okay, and then let's substitute. So T91 is going to be 7 plus 91 minus 1, and then times 5, right? So we can just put this thing as it is in the calculator. 7 plus 91 minus 1 times 5, or 7 plus 90 times 5. Okay, then what do you get? T91 is equal to 457. That is term 91. 212, find S91. So we're finding the sum of the first 91 terms. Remember the formula Sn is equal to n over 2, then 2a plus n minus 1d, like that, right? And then we have our a, we have our n, we have our d. So we substitute into the formula. So S91 is equal to 91 over 2, then 2 times 7, then plus 91 minus 1 times 5, right? Then you can put this in the calculator. Then S91 is equal to 21,112. And then the other thing you can do here is to use this formula Sn is equal to n over 2, and then a plus l, where l is the last term. So we have our l here. We already got it from our 211. So we can use that. S91 is equal to 91 over 2, and then we have 7 plus 457, right? And then what you get, S91 is equal to 21,112. Okay, right. Let's do question 213. Calculate the value of n for which Tn is 517. Right, so it means we're still using Tn. So Tn is equal to A plus n minus 1d. So our term is 517. Then 517 is term number what? We're finding n here. So our term is 517, right, is equal to our A. Our A is what? Is 7. Then plus n minus 1. N, that's what you're looking for. N minus 1. And then difference is 5. Okay. You can distribute 5 here. Get 517 is equal to 7 plus 5n, and then minus 5, right? 517 is equal to 5n plus 2, right? Let's subtract 2 from both sides of the equation. 515 is equal to 5n, and then therefore n is equal to 103 after dividing by 5 on both sides of the equation. So 517 is term number 103. Let's do question 221. The following information is given about a quadratic number pattern. T1 is equal to 3, T2 minus T1 is equal to 9, then T3 minus T2 is equal to 21. Show that T5 is equal to 111. Right. Usually I use this diagram. T1 is 3. Okay. Then T2 minus T1. So it means the difference between T2 and T1 is 9. That's the difference. And then how do we get T2? We just have to say 3 plus 9. Then we get our 12, right? Then this is T2, 12 is T2. And T3 minus T2 is 21. So it means the difference between T3 and T2 is what? 21. Then what is T3? 12 plus 21, which is equal to 33. You see, so the quadratic pattern is what? 3, 12, 33. It goes on like that. So to get T5, we can simply extend this. Remember, the second difference is what? Is constant. 21 minus 9, we get 12. Right? So it means here we have 12 also. So 21 plus 12 will give us what? Will give us 33. Okay. And then 33 plus 33 will give us 66. So term 4 is 66. And then 12, that's the second difference, because for a quadratic pattern, the second difference is constant. 33 plus 12, that is what? 45. Then 66 plus 45, that is 111. So therefore, T5 is equal to 111. We've proved that. The other thing you could have done after getting this, you see that we have 12, 9, 3. Remember what we do. We can find our general term. And then after that, substitute n with 5. But let's find the general term. We equate this to 2a. That's the simpler method. And then 3a plus b. Then a plus b plus c. Right, so 2a is equal to 12, meaning that a is equal to 6. Then 3a plus b is equal to 9, meaning that 3 times 6 plus b is equal to 9. Then b is equal to 9 minus 18. 9 minus 18 is negative 9. Then a plus b plus c is equal to 3, meaning that 6 plus negative 9 plus c is equal to 3. 6 plus negative 9, that is negative 3. Negative 3 transposed to the right hand side becomes plus 3. C is equal to 3 plus 3, c is equal to 6. We have proved that Tn is equal to 6 n squared minus 9n plus 6. And then where there's n, we put 5. So T5 is equal to 6, and then 5 squared minus 9 times 5 plus 6. And then we get our 111. Right, question 2.2. Question 2.2, we have already done this. Question 2.2. So what we have done here, finding our Tn. This proves that our Tn is equal to 6n squared minus 9n plus 6. So this is 222. So there's no need for us to repeat the same thing. Okay, 223. Right, show that the pattern is increasing for all n element of natural numbers. What are natural numbers? Natural numbers are the numbers that start from 1. Okay, natural numbers start from 1, 2, 3, they go on like that. Okay, these are natural numbers. Remember, whole numbers start from 0. Natural numbers start from 1. These are counting numbers. So when it's increasing, we know that the derivative, remember the derivative is the gradient. The derivative is the gradient. So it means the derivative will be greater than 0. The derivative will be positive. When the derivative is positive, it means the gradient is positive. Therefore, the function is increasing. Tn is equal to 6n squared minus 9n plus 6. So derivative of n there is 12n minus 9. Then this derivative should be greater than 0. Okay, all right, and then we solve for n. 12n minus 9 greater than 0. 12n greater than 9. Then n is greater than 9 over 12. Okay, meaning that n is greater than 3 over 4. Right, n is greater than what? 0.75. And remember, n can only be a natural number. So it means n will be from 1 onwards. The other thing we can do is to say that this is parabolic, isn't it? This is parabolic, and since a is positive, so it means it's concave up like this. All right, it is concave up like this. So it has a minimum value. Let's use the axis of symmetry. So we can use n is equal to negative b over 2a. Remember that from functions. So n is equal to negative 9 over 2 times 6. And then what do we get? We get that n is equal to 3 over 4, right? 0.75. So it means this will be n is equal to 0.75. But remember, n is the number of terms. It can only be a natural number. So it is increasing from where? It can only be increasing from 1 onwards. So when n is 1 or more, that's when the graph is increasing. But remember, n can never be a decimal. It can only be a natural number. So therefore, Tn is increasing for an element of what? Natural numbers.